Hello everyone, today let's see how to create an array dynamically. Before we create a dynamic array, let's see why we need to create a dynamic array. Here in this example, you can see that we are creating a static array of size 8 and initializing it to 0. Now we are taking a number from the user and we are inserting those number of elements into the array. Now let's see what happens here. For example, if I give a number as 3, we get 0, 1 and 2 as the output. Here we are printing the size of the array, which is equal to 32. Since the size of an integer is 4, 4 into 8 is equal to 32. Now effectively we are wasting 5 memory locations which are used by the array, and we are using only 3 memory locations to read or display the numbers. So when we are doing static allocation, we are wasting the number of memory locations which are not used by the user, but those memory locations are actually occupied in the memory. So we are wasting the memory space for a program. Now for example, if we have created an array of size 100 and we are using only one memory location, then we are wasting 99 memory locations of that array. So we can avoid this by using dynamic memory allocation. Let's see how to do dynamic memory allocation. In this example, we are creating an array named dynamic array using dynamic memory allocation. To do dynamic memory allocation, we make use of this function malloc. This malloc takes the size of the array as an input. Here size of the array is not actually given as 5 or 4 as an integer representation which is given in static allocation, but here we have to give the number of memory blocks that are required by the array multiplied by size of the data type. Malloc actually returns a void integer, a void pointer. So we have to typecast it to int star to make it an integer pointer. Here dynamic array is the pointer to the array. It actually points to the first memory location of that array, that is the starting memory block of the array. Now let's see what happens in this example. Since we have not initialized it to any value, we are only having the garbage values as the values in the array. So here you can see that there are only 5 memory blocks that are used by the array, and we are not using any excess memory blocks. After using a pointer, we must be sure to free that pointer so that it would not cause any memory leaks. Now if the user has created 5 memory locations and he needs some more memory locations to operate on that array, what can we do? We cannot reallocate the array by using malloc, because malloc actually creates a new array to the pointer. So if we use malloc, we may lose all the data in that pointer array. So we can use the function realloc. In this example, we can see that we are creating a pointer dynamic array and we are using the function malloc. Actually, the function malloc returns a void pointer. Since we require an integer pointer, we are using int star to typecast it into an integer pointer. Now we are giving 5 into size of int. What this says is, I need 5 memory locations of size int. We know that the size of integer is 4 bytes. So we are saying that I need 5 memory locations with each memory location being 4 bytes. Now this dynamic array pointer points only to the starting memory location of an array. For example, if the user needs 5 locations and he has used all the 5. Now what if the user needs more than 5 locations? What if the user needs 10 locations? For that purpose, we can use realloc. What realloc does is, it takes the pointer which is returned by the malloc and increases the size of that array by n number of memory blocks. Let's see how it does that. Now, if the user needs 5 more memory locations, he has to give the size of the array plus number of memory locations he needs. Here we can see we have 10 here. We can also write this as 5 plus 5. What this essentially says is, I have created 5 memory locations previously using malloc, and I need 5 more memory locations. So we basically write this as 10. That is, we give the input of the second parameter as the total number of memory locations that are required for that array. Now let's see what happens if we execute this. You can see that we have 0, 1, 2, 3 and 4 as an output in the first statement. We have used malloc to create only 5 memory blocks for the array, and we are assigning I to each memory block. So here we are not wasting any memory block. When coming to realloc, we have increased the size of the array by 5 more blocks. That is, now the total size of the array is 10. Same as the above statement, we are assigning I to each memory block of the dynamic array. Now we can see that there are 10 elements in this dynamic array. So we have effectively increased the size of the dynamic array from 5 to 10. Here we are not wasting any of the memory blocks. After executing all the statements in a program, we must be sure to free the array. That is, to free the pointer which is pointing to the array. If we do not free this pointer, it can cause memory leak. I have attached some links in the description. Please do read them. Thank you for watching.